In this exercise, we're going to discuss creating holes. Hole Command Inventor is very easy to use and it's a very powerful tool. So let's get started. I'm going to go up and click the hole command. First off, you'll notice that I do have the little mini toolbar, but there is no roll up here other than whenever you click on a couple of the different options. There's so many different options, there's just no way to create a mini toolbar. With any Inventor command, or really any Autodesk command, you work top to bottom, left to right. It's like reading a book. So the first options that we have is which kind of hole we want to create. We can go from a sketch, linear, concentric, or on a point. Linear is what you're going to use 90% of the time. I'll show you that real quick. If I come onto this face and I select it, it tells me once I select the face to select reference line 1. And what that means is I just select an edge and I can type in a number. It's asking me for the second line. If I look down here in the bottom left-hand corner, or you notice that the arrow is still red. So I type that in, give it a distance. So now I have located this hole. Like a lot of the features in Inventor, it is heads-up design, meaning that I can come over here and grab it and tweak it. But most of the time when you're creating a hole, you're going to know kind of what that dimension needs to be. The next option is what kind of hole is it going to be? Is it just going to be a straight through hole? Is it going to be a counter bore hole? Is it going to be a spot face hole? Or is it going to be a countersink hole? For those of you not familiar with spot face, this is basically if you have an irregular surface and you need to create a flat spot before you start to drill or tap into a part. You'll see this a lot of time on cast parts that are rounded or slightly rounded, just so that the drill bit will want to walk if the face isn't good and flat. And so what they'll do is they'll go in with a larger bit and just kind of waller out a spot to give it a flat spot, and so it's a spot face, and then they'll drill in the center of that. For the use of this exercise, we'll do a counter bore, just so we can take a look at it. Our options right away tell us what kind of hole information we're going to give it. We can say, okay, I'm going to do a 0.25 inch hole. Then it asks what size counter bore is that going to be? Say 1/2 inch. And then how deep do we want it to be? 1/4 inch is fine there. Next option you'll notice is grayed out if I come down here. And the reason is because this is set to through all. If I change this to distance, you can actually edit the drill point. The reason is the drill point is what it's going to look like in the bottom of the hole if the hole doesn't go all the way through the part. About the only time I've ever messed with the drill point option is I had a air reducer that actually had a slope bottom in the bottom of the hole, and then it had a tiny little hole, and that was like a air valve or a air gauge or something like that, so that it was kind of a choke point, reducing point. And so I messed with the drill point then, but most of the time you just leave that at 118. That's kind of the standard drill bit point. You know, no hole is ever going to be drilled completely flat like this. The only time you'd ever do this is if you were doing a hole that you were going to be like molding or something like that, where you actually could have a flat bottom hole. But most of the time, you know, a drill technically is going to have a little bit of a point to it. Next option is termination. Through all basically says the hole's going to go all the way through the part. 2, you can actually say, okay, I want it to stop on this face. And then distance. If I come in here, you'll notice the distance actually is a new measurement up here. I could say 0.5. And you can see the drill point inside my part there, not going all the way through. Pretty straightforward. Down at the bottom, what kind of hole do we want it to be? Right now it's just a simple hole, meaning that we tell it what diameter we want it to be. The next option over is a clearance hole. And what this does is this lets us come in here and say, okay, this is going to be a socket head cap screw, 1/4 inch. And you'll notice that my measurements up here changed. And this gives it enough clearance, basically, to fit a 1/4 inch socket head cap screw in here. Notice the hole diameter is no longer 0.25, it's 0.266. This allows for the threads to actually go through here. Down here at the bottom, the option we can either do close, normal, or loose. Close is like a hole if you're ever working on something and you've literally had to kind of thread, you know, even though it's not a threaded hole, you still gotta kind of turn the bolt to get it to go through the hole because it's so tight. So if you change it to close there, you can see it goes down to 257. So you only got 0.07 clearance in there. and then loose, it lets it go the other way. A lot of times I'll do loose if I do powder coat or paint, because you're going to have a couple thousandths of paint in there or powder coat. So you do the loose hole, and that'll allow you a little bit of gap for that hole to get filled in there. Once we get everything set, we hit OK. And then we'll come up here and we'll look at the next hole. So I'm going to start the hole command again. You'll notice that it automatically jumped to from sketch because I had an active sketch here and it wants to try to find, that active sketch for me. Now these holes are pretty close together, so I can't use that. And I want to make these threaded holes for whatever reason. And these holes are pretty close together, so I need to come down to, number 8. And so now what it's going to do is it says it's going to create a bunch of threaded holes for me in this part that are for number 8 ANSI screw. Tells me the thread designation, what class it is, is it going to be full depth or right or left-handed threads? In a situation like this, you can uncheck full depth and you could actually drive and say, okay, I'm going to actually pre-drill this and I'm only going to thread down so far for whatever reason. Most of the time I do full depth. Very rarely have I ever had to, thread down. I mean, in reality, usually you don't tap all the way to the bottom of the hole, but it's so close to the bottom it doesn't matter. So we can hit OK here, and you'll notice that it put the threads in there for me. Now the threads are not threads. They are just bitmap references. Even then, that's kind of excessive. If you've got a great big giant 10,000 part machine, it's really not necessary to put the threads in there. You can just put the holes in there, whatever size you want them to be. The threads are not real threads. I can't zoom in and see the pitches of the thread. And the reason is because the mathematical overhead of calculating a helix going through that hole is huge. Just this number of holes here, if these were actual cut into the part, would use as much memory as 4,000 or 5,000 part assembly. So you definitely do not want to add threads whenever possible. You don't even want to add the bitmaps, but there really is no reason to ever cut the threads. Unless you're designing something, if you're designing a screw or you're designing some kind of screw shaft or something like that, where you're actually going to be cutting the threads on a CNC and you need to give the CNC information more than just the thread and pitch. This will actually tell it, okay, this is this size thread and pitch when you put it on a drawing. If you're going to pass this over to a CNC machine and they're actually going to go in there and cut these threads and it's got to, realize the 3D geometry, then you can draw them in there. But most of the time you're going to buy this stuff. You're not going to be creating threads. Unless you're making screws, there's no reason to ever cut threads. Stay away from that whenever possible. But you can see it looks nice. Gives me my nice little threads there. You'll notice that some of the holes don't go all the way through, so those actually get the drill point and bottom. So now I have my block of threaded holes there. The next option we'll look at with the hole command is concentric. And I'll click on this plane, and then it asks for a concentric reference. So I can say the edge there, and basically what it does is it puts it on the center point of this arc. In this situation, let's say I'm going to have this tool have the ability to screw in a pipe to hold it. This is going to be some kind of mounting bracket for something. So then what I can do is I can use the tapered hole option. And you can see that this is basically pipe threads. So I could say, let's do 1.5 inches. Still too big. 1 inch. Take it down here small enough to where we can actually see it in our part here. So we go 3/4. So what this is going to do is this is going to actually taper out the way a pipe thread works. So I hit OK. You can't really see it. If I look at top here, the way pipe threading works is it's actually, a slight draft on it so that the pipe can get started. And so that's actually a pipe thread hole. So we can add that in there. And then lastly, the last hole we can take a look at real quick is on a point. Say this is our point. Then it asks for the direction. I can click on this face, and so now this hole, I'll just do a simple clearance hole here, and I'll say through all. So this hole is going to be perpendicular to this face, basically. I could have just clicked on the face for this one. Where this comes in really handy is if you had a round object. If you were going to take and put a hole in the side of a round object, you could go in there and click on the side of the round and have like an axis through the side of that part, and the hole would follow that axis. So if you didn't have a perpendicular face basically to start from. One last thing I was going to show you is holes in sheet metal parts. They work exactly the same, and I highly encourage you to use the actual hole command when you're creating holes in a sheet metal part. But if you have irregular shaped holes in a sheet metal part, then you can use a cut command. And it looks very similar to the hole command. The only thing is you don't get any hole information. For example, if I come in here and I put a hole in here, and I put this information in here, and it's actually a threaded hole, whenever I go to dimension this on the drawing, I can click on the hole and it'll say this is a hole with this size threads. Whereas a cut in a sheet metal isn't going to understand that it's a hole. It's going to understand that it's an opening. It's a subtle difference, but the reason I mention that to you is because I encourage you to use the actual hole command whenever possible. If it's round, it needs to be a hole. Don't use the extrude command. Same with the standard parts. We could actually just extrude out a hole, but then whenever you go to dimension that drawing and put that into an actual drawing, it's not going to understand that it's a smart hole. You know, you've heard of smart holes before, you probably work with one, but these actually have that information with them, and that information will tell it, what size thread it is, what size hole it is. The threaded holes actually are, a little bit smaller than the actual hole because you got to go in there and tap it. So it understands that, for a 1/4 inch threaded hole, it needs to be a little bit smaller. So whenever you cut the threads, you're actually going to remove a secondary option in there. So there's some things like that that are very important for holes. So try this, play along with this part a little bit and see what fun you can have. It'll be under creatingholes.ipt and then creatingholes-sheetmetal.ipt. So you can take a look at this and see what you can do.